So I want to welcome and thank everyone for attending the IEEE Electronics Packaging Society webinar. My name is Denise Manning, and I will be administering the webinar. At this time, I would like to introduce today's host, Ken Pyle, co-founder of VOD and managing editor of the VOD View. Ken will be introducing our presenter and reading any questions at the end of the presentation.
Thank you, Denise, and thank you, everyone, for your attendance today. I'm pleased to welcome you to today's webcast from the IEEE Electronics Packaging Society. It's being broadcast worldwide. I invite you to post the questions through WebEx, and we'll try to answer some of them during the final 10 minutes. So with that, I'm pleased to have Paul Wesling by my side. He's our speaker, and he's going to be talking about how Silicon Valley came to be. Paul Wesling is a Life Fellow of the IEEE. He received the IEEE's Centennial Medal, the board's Distinguished Service Award, the Society Contribution Award, and the IEEE's Third Millennium Medal. He's spoken around the world on entrepreneurial developments in the startup environment here in Silicon Valley, and that is where we're broadcasting from. So, Paul, why don't we start with a little bit about your career and your journey to Silicon Valley?
Okay, well, I came to Stanford University and majored in electrical engineering and got a master's in material science. And then I had job assignments in quite a few EPS-type fields, including component engineering, several years in manufacturing technology. I worked on bubble memory development back in those days, and it tested mainframe computers and also developed multi-chip module designs. And I've been close to the startup scene here in Silicon Valley. I've had 3 startups fail from under me, which was kind of exciting.
And all that time, I mean, as if you didn't have enough things going on, you were active in the Santa Clara Valley as an IEEE volunteer.
Yes. In the early 70s, I was treasurer and then chair of my local EPS chapter. And then I became the chapter advisor. And I continued as advisor and organized over those years about 300 technical and professional skills classes for engineers here in the Valley. I was appointed secretary of the society back many years ago, and then served as vice president of publications for about 22 years. Had 4 journals, a magazine, a newsletter, several IEEE press books. And during that time, the incremental revenue from the transactions from the work I had done generated about $4 million in excess money that went into new programs into society reserves. So that was kind of my fun stuff.
Yeah, I understand that you took an early retirement from your engineering career.
Yes, I was at Tandem Computers for 17 years. It was acquired by Hewlett-Packard, and I took early retirement in 2001, and then I served as Mr. IEEE for the San Francisco Bay Area's IEEE Council for the next 10 years, expanding their Grid magazine. We had about 18,000 subscribers when I started. We had about 32,000 at the end, and generated advertising revenue of about $70,000 a year, which went, the surplus on that went to operate the sections. And so now I'm serving as a IEEE Region 6 instructor, showing other sections how to do what we did here in the Valley.
Well, you truly are Mr. IEEE. So, Paul, thank you for that. And now, if you can give us a summary of how it all happened here in Silicon Valley and the startup of the Electronics Packaging Society and some of the influence on the IEEE itself.
Good. Thanks, Ken. Yes, I'm going to start with a story that most of you are familiar with, the classic Silicon Valley story of the Homebrew Computer Club up in Menlo Park, a group that met together. And a couple of fellows got together. Steve Wozniak took the 6502, a brand new, fairly inexpensive $20 microprocessor, was able to use the Motorola peripheral devices, and he and Steve Jobs showed off this Apple I, and his objective was to sell it to his friends. They formed a partnership, called it Apple Computer Company, and it started in a garage, which is kind of how things are supposed to happen around here. And now it's got the largest stock market capitalization in the world, and it's the most valuable brand in the world. So the question is, how could this happen? And why, in fact, did it happen in the San Francisco Bay Area? That's really the question. And I think when you get done listening to this, you'll understand why it happened here and what's going on that's kind of special here. Well, back in the 1900s, actually before the 1900s, this was called the Valley of Heart's Delight, and it was primarily agriculture. One of the first companies, electronics companies, was Federal Telegraph, and it was formed in 1909 by a Stanford grad named Cyril Elwell. And he dug into radio, which was just starting to happen. And he was able to hire Lee DeForest. You electrical engineers recognize him as the inventor of the vacuum tube. Well, he was here from 1910 to about 1912 and invented an improved Audion tube, which was used for circuits. He developed two circuits, one for amplification and the other one for oscillation. And so that happened in the labs here. And at Federal Telegraph, Cyril Elwell licensed the pulse and arc transmitter from Denmark. As you see one on the right here. And he raised funds from what we would today call angel investors, including David Starr Jordan, the president of Stanford, and several professors and others around here. Jordan invested $500, which today would be about $20,000, in getting this started. And he was able to demonstrate communication from San Francisco to Honolulu and back, putting a radio link in so they could communicate very quickly with Honolulu. And this was a demonstration of the first venture capital, and also Stanford's involvement with some of its grad students in starting up their businesses. Well, also in that time, broadcasting was just getting started, and Doc Herhold, Charles Herhold, who was an early Stanford student, started a company in San Francisco, but it was destroyed by the earthquake in 1906. So he moved to San Jose and started a school to teach radio arts here in San Jose in 1909. And he did the first commercial radio broadcast in San Jose called San Jose Calling. Every Wednesday night he would have a radio broadcast for his students to listen to. It was called Station FN. Now it's our big KCBS station. Another example, Otis Moorhead was a Stanford grad, and he liked making vacuum tubes, so he established his own company in San Francisco called Moorhead Laboratories. And he didn't have any new designs, but he thought, I can make these tubes that I see here, and he started making them. Well, you can make 100 tubes and get away with it. A few thousand, somebody might notice. So the East Coast companies noticed, and they filed a patent infringement lawsuit and put him out of business. And that's going to be a theme of this talk. So the defining events of those days, there was a lot of independent wealth in California. The gold rush had created quite a bit and was still creating a lot of money for San Francisco and Oakland and San Jose. The Titanic sinking in 1912 was a big event because radio played a big part in the rescue, and also the fact that they couldn't get information out quickly enough because the Carpathian radio operator had already gone to bed. Also, World War I emphasized the importance of technology in warfare. And so after the war, the U.S. Navy pushed for more ship-to-shore and other communication modes that could be useful for them in setting up a good defense. Economics also played a part. For example, it was expensive to string telephone and telegraph lines all over the place. And undersea cables, there were some during those days, but they were notoriously unreliable and, of course, very difficult to repair. And wouldn't it be nice if you could wirelessly send information across the ocean without having to lay all these cables? And that brought a lot of funding to the San Francisco Bay Area. We're going to follow three early pioneers. Bill Eitel, Jack McCullough, and Charlie Litton came from Bay Area families, a lot of entrepreneurship in their families. They were born and raised here. Charlie Litton, you can see him on the right. That door there says wireless house, and he at 11 years old had his own experimental radio station out in his backyard. So they were definitely techies in those days. Bill Eitel went to school in Los Gatos, went to high school there. His father had a quarry in the Santa Cruz Mountains, and he got used to repairing equipment, helping to run things during his high school years. Also, his uncle had a company up in Oakland called the Hall Scott Motor Car Company. And there he learned to operate complex machinery, fix things, make jigs, things like that. And then Jack McCullough and Charlie Litton attended the California School of Mechanical Arts, which was probably one of the best West Coast technical high schools. And Litton said he gained a realistic feel for materials and processes going to high school in San Francisco. And that's, of course, the Electronics Packaging Society's fields of interest, those areas. Well, McCullough went on to a local junior college, and Litton enrolled at Stanford in mechanical engineering. And he got his BS in 1924 in mechanical engineering. And that's just when communication engineering was becoming a course. And so he took Stanford's first course on communication engineering fundamentals in 1925. So Eitel, Litton, and McCullough had been introduced as kids to amateur radio, what we call ham radio. Their families were active in this kind of thing. A lot of friends were around. And ham radio was pretty big in the San Francisco Bay Area because we had a lot of shipping companies that needed radio operators. And over 1,200 licensed amateurs in the early 20s were in the San Francisco Bay Area. So that was about 10% of the U.S. Population of hams, which was kind of a bubble. And we notice the bubble now, but they probably didn't in those days. This was an active center for radio production in the 1910s and 20s. We had a number of firms here, electronics firms that would be familiar to us as manufacturing and process engineers. Remler made radio sets. Magnavox, we know them today for speakers. They started in Napa and moved down to Oakland. Heinz and Kaufman designed custom radio equipment for what we call the HF bands. And Federal Telegraph, which I mentioned, they were producing million-watt transmitters, which were installed in Spain and the Philippines and the Canal Zone and the east and west coast of the USA for radio communications. Also, because of all of the manufacturers, there were lots of parts available for local hobbyists. So if you got interested as a teenager, you could find parts available from friends or from down the road or something. And there were also lots of jobs for people who understood radio or were active in it. For example, on shipboard communication and things like that. So it was quite a subculture. It was a good way to make friends because they could communicate over the air with some other people that they knew or didn't know, and also face to face. And that's kind of nice for geeks like me. For example, we don't like talking to other people really. It's kind of a difficult thing for techies sometimes to do, but we can always talk about what we've just done recently in our hobby, our communications hobby, or show them what we've built and things like that. So it's kind of a nice thing for techies. It was also very egalitarian and democratic. There was very little distinction based on class or background or job or education. And Bill Eitel, when he was chairing the Santa Clara County Radio Club in the 1920s, he said they had farm boys and Stanford students, Federal Telegraph technicians, and retired executives all working together on the same hobby stuff, much as Steve Jobs and Steve Wozniak in the Homebrew Computer Club. Well, there was a lot of interest in extending this radio technology, and the way that people did it as ham radio operators was to try something new, maybe talk to somebody farther away than anybody else, or on a band that nobody had used before, or innovating new transmitter circuits, or new ways of doing things, or better antenna. And so they like to do this as kind of the first one, that's the competition side, but then they love to show other people how to do it. They would demonstrate to you how to make that happen. So it was a mix of competitiveness and collaboration, and we see that a lot in the Silicon Valley today, and we'll explain more about that as we go along. So it's a lot like that Homebrew Computer Club and what we see today in the Valley. Well, another young pioneer came along in those days, young Fred Terman. He was one of the faculty brats on the Stanford campus. His dad was a professor there. If you've ever taken a Stanford Binet IQ test back in the 60s and 70s, that was his dad that developed that, Lou Terman. And so they experimented a lot, and they had Herbert Hoover Jr., who lived across the street from the Termans. It was the son of the mining engineer who became president of the United States, and Roland Marks, son of the civil engineering professor. George Branner, son of the geology professor, and Jack Franklin was the son of the head of the chemistry department. And Herbert Hoover Jr. said, all three of us were neighbors, and upon pushing the key of one of our imposing contraptions would holler out the window to see if it had been received on the other side of the street. A bunch of kids playing with technology, and we see that today around our valley. Perhaps you see it in your area too. Well, young Fred Terman said that if you saw a 90-foot pole sticking up somewhere, you'd go knock on the door and get acquainted with him, because obviously he was involved in radio and you could learn something or watch what he was doing. He also hung out at Federal Telegraph, which was a bit down El Camino from Stanford, and he worked there one summer during his college years. So he got involved in radio. It was kind of a neat hobby, and that's what got him into engineering. Well, these were all fellow entrepreneurs in the same technology area, didn't necessarily know each other real well then, But Litton, after graduating, got a job through a local ham friend doing the research at Federal Telegraph, the company that Cyril Elwell started that I mentioned initially. Eitel got a job also through a ham friend at Heinz & Kaufman, one of the other radio companies here in the Bay Area. Heinz himself was a ham with a focus on producing high-end, high-frequency radio equipment, and he recruited Jack McCullough a year later to join them. And on the right you see their buildings on Emerson Street in Palo Alto. On the left, that little building with one window is where Lee DeForest had his couple of technicians in his lab. So the tube business in those days was dominated by General Electric, Westinghouse, and AT&T on the East Coast. And they developed high-powered transmitting tubes in the early 1920s. And they were difficult to make. They took precise machining, glass blowing with Pyrex glass from Corning in New York, precise alignment, and used exotic materials and difficult sealing techniques to keep the vacuum in there. They were not that reliable. It was a challenge for them. After World War I, you couldn't buy these transmitting tubes on the open market. They were restricted. The Navy and General Electric set up a new company called Radio Corporation of America, or RCA, to ensure dominance by the United States in this new technology. And they had exclusive cross-licensing agreements on the key radio patents, and they refused to sell tubes or license the patents to our Bay Area firms because we sold internationally to France and China and different places, and it was seen as a threat to RCA and U.S. control of this new technology. So both companies locally needed to develop triode tubes. So Litton headed up one shop, and Eitel headed up the other tube shop. Well, their challenge was to design around these key RCA patents. And Eitel and Litton collaborated together with each other, which you wouldn't typically see in companies back in those days. But it was based on their friendships over the years and also their need to develop devices that would work with their radios. They also worked closely with patent attorneys to make sure they didn't infringe patents and also to patent their own new developments. Heinz and Eitel and McCullough over at Heinz & Kaufman engineered a rugged new power tube with new materials that didn't violate the patents, better manufacturing methods, and new shock-resistant seals, and they were able to create higher vacuums, which gave them a lot better reliability. So they were more reliable and longer life than the RCA tubes, but the key was they didn't infringe RCA's patents, so RCA couldn't sue them. Process improvements. Well, this is a key part of electronics packaging. Litton was a master in that area. He invented the glass lathe, which you see in the lower right, on which you could assemble and blow the glass for the tube, put all the pieces in there and seal it all on one axis. And it was very stable. You could make complex tubes in large quantities very repeatably, good reliability. So we now come into the 1930s, and the United States was in a depression. Eitel and McCullough formed their own company, which we know as IMAC, to build high-power, high-frequency tubes primarily for the amateur radio market. That was their focus. They got financing. They didn't have any money themselves, so they got $2,500 each from Harrison, who was a real estate agent, and Preddy, who had a string of movie theaters. Eitel and McCullough brought their know-how, and they split the ownership and profits 50-50. So there's an example of venture capital. Harrison sold his $2,500 investment about 10 years later for about $55,000, and Preddy sold his after World War II for about $250,000. So here we have the growth of venture capital and the payoff. So again, Litton, Eitel, and McCullough cooperated closely. Litton helped set up the IMAC vacuum tube shop as they started their company up, and he gave them castings for this glass lathe that he had invented and also the blueprints for it and let them make their own. So they freely exchanged technical information and also commercial information to help each other. And this reduced the risks because they were two small tube-related businesses competing against bigger opposition, and so they worked together on it. Kind of like Steve Jobs and Steve Wozniak and the Homebrew Computer Club. Well, in 1936, Fred Terman asked Charlie Litton, to join Stanford's EE department as a lecturer, not as a professor, but to help out in the labs, help instruct the students, help the staff. There was a $1,000 grant that Terman got, and with that he contacted David Packard, who was working at General Electric on the East Coast, and said, You and Lucille can live on $55 a month, and that leaves me $500 you can use for lab equipment. And so Dave Packard came back to work on his engineering degree, met Bill Hewlett, who had developed a new circuit for an audio oscillator that was stable as you varied the frequency, which was kind of a neat thing. And they formed Hewlett Packard in the garage you see in the lower right. So here again we have the university industry cooperation that we saw earlier on in starting Federal Telegraph. Well, there was a growing threat to peace in the late 1930s from Japan and Germany. President Roosevelt was rebuilding the Army and the Navy, and they needed new technology. And in England, a system had developed called radio detection and ranging, or radar. And it was kind of neat because you could send out a ping of radio energy and you got this image back, and it gave you a feeling, depending on the time of flight, of how far it was away from you. It was ranging. You could detect it and you could get a feel for how far away it was. But you couldn't tell much about it. What they really needed was higher voltage and higher frequency transmitting tubes. And the only ones that worked best for that application were IMAX tubes, which were optimized for ham radio. So those are some of the ones they used to develop better radar systems. The klystron was another key development in the late 30s. You see Russell and Sigurd Very in it when they were boys in Palo Alto over on the right. And they hoped to use microwaves to detect planes, because microwaves, being of much higher frequency, maybe you can detect more about them. You might see the size of the plane, maybe even tell what kind of plane it was. Anyway, in 1937, Russ Varian moved his work to Stanford's labs and worked with Bill Hansen, the physics professor. They worked back and forth, trying different things, and finally they developed the klystron in 1937, which klystron is really an integrated circuit. We won't go into the klystron itself, but it was, I call it the first integrated circuit. It used Litton's free advice on how to build things. Litton helped him optimize the manufacture of them, and Hansen's theoretical assistance. And on the right, you see the brothers with about a 15 kilowatt klystron. So probably only in Palo Alto. This is the headlines in January 30th, 1939. And you see on the left, President Roosevelt talking about building up our war capability. On the lower left, you see Adolf Hitler saying, just give me one more country. Give me half of Poland and I'll be happy. But the real headline I've circled, it's New Stanford Radio Invention Heralds Revolutionary Changes. And you see Sigurd and Russ Varian, and this is the disclosure of the development of the klystron. So Sperry, back in New York on Long Island, invested in it and got exclusive rights. They bought lathes and welders and pumps from Litton, who, as I say, was our key manufacturing and process development engineer. He stayed out here in Silicon Valley, made klystrons for IT&T for France until France fell to Germany. And they transformed the klystron from a lab curiosity into a production device. He's the guy who helped make it a highly producible item. And he became the microwave design arm for IT&T, International Telephone and Telegraph. And he went on to develop other tubes, the continuous wave klystron and VHF and radar tubes. And Stanford and the Bay Area became a microwave hotbed. A lot of development happened here. So wartime, there was a big expansion in the microwaves area. A lot of the technology, of course, moved back to MIT and Harvard, to the labs that the U.S. government set up there. But after the war, they came back to the Santa Clara Valley. And the companies here had a pretty progressive approach to business during and after the war. It was very egalitarian, not much class distinction between quality engineers, manufacturing engineers, designers, the marketing people, and so on. And also they developed new ideas. Profit sharing started back in those days, tuition reimbursement for engineering education. They developed cafeterias in their companies so people could stay on site a lot longer. Kaiser Shipbuilding put in medical clinics, which became the Kaiser Permanente hospital system. And it was similar to what we saw at Hewlett Packard and Fairchild, Intel, Tandem Computers, where I worked for many years, in the 60s, 70s, and 80s. And at Tandem Computers, I remember we had one rule that we learned when we first got there that said, in a meeting, if somebody has a new idea, you can't say anything bad about it for 5 minutes. The idea that you have to support other people and not shoot down new ideas. Let's innovative ideas come forward that you can consider. So that was kind of that cultural effect of these companies, and based on the old ham radio paradigm. So after the war, RCA and others focused on television and broadcast. Television was invented here on the peninsula too. IMAC developed a new line of better tubes, power tetrodes that could go to even higher frequencies. And the Federal Communications Commission of the United States set this new FM band. And it was supposed to be around 50 megahertz, but they surprised everybody and put it up around 100 megahertz, which is where we're all used to seeing it now. Unfortunately, RCA's tubes didn't work at that VHF frequency, so they did the next best thing. They copied the IMAC tubes, which did work. So now they had something that worked, but IMAC sued RCA and General Electric in 1947 for infringing their patents and shut them down. So now they became marketers for the IMAC tubes. So the big dog now was Silicon Valley. After the war, Charlie Litton focused on these high-power klystrons, and he scaled it up from 30 kilowatts up to 30 megawatts, which made Stanford a major player, and the Bay Area companies such as Litton and the Varian Associates. And they developed linear cell accelerators, including this 2-mile-long linear accelerator you see here, which they used for a lot of physics research. Several Nobel Prizes came out of the physics research there, and we see it today in cancer radiation treatment. Every time somebody gets radiation treatment, they're using a Litton klystron. Varian Brothers started their own company. Rather than Varian Corporation, it was Varian Associates. It was a loose group of about 10 or 12 people that felt they could develop new things and markets and see what happened. Well, they were developing microwave equipment, and part of that was making some measuring equipment so they could measure the efficiency and output of microwave equipment. But they didn't want to make this measuring instrumentation, so what they did, they went to Hewlett-Packard and says, well, for $20,000, we'll sell you the rights to this and show you how to make these, and you can make these instruments because you're making audio oscillators and other neat things. And this let Hewlett-Packard expand its product line into a whole new area. And they started their Santa Rosa and Santa Clara divisions, which became Agilent, and now it's Keysight. And in the lower left, you see their very first product, their audio oscillator, and on the right, you see Dave Packard and Bill Hewlett. This is a mural that's in Palo Alto, and it shows graphically kind of what happened in the valley. So you see Stanford in the background, but in the upper left, Leonard Fuller and Cyril Elwell at Federal Telegraph, and behind them, that huge pole piece of a magnet. They had an extra one, so they gave the 42-inch magnet to Ernest Lawrence up at UC Berkeley, and he made a 42-inch cyclotron. And his work on nuclear physics resulted in 6 Nobel Prizes before 1960. On the left, you see Doc Herhold at his broadcasting station, broadcasting to Palo Alto. In the lower left, you see Charlie Litton with his glass lathe working on building a tube. And in the middle, there's Fred Terman talking to Dave Packard and Bill Hewlett, and you see their audio oscillator. Philo Farnsworth on the right, who invented the electronic television tube, and others. This was kind of a graphic look at what happened in that early 30 years or so of the 20th century. Fast forward to the 1950s, and we see William Shockley. He was raised in Palo Alto. You see him there with his dog in Palo Alto. He went to Caltech and then got his PhD at MIT and went on to Bell Labs, where he and John Bardeen and Walter Brattain invented the transistor. This was a germanium point contact transistor, but that was kind of a neat development because you could replace, hopefully, these high-powered hot vacuum tubes, unreliable vacuum tubes, with something solid state that used a lot less energy. So that was the objective there. Shockley left Bell Labs, and he taught for a year or so at Caltech. And Arnold Beckman approached him and says, well, I'll fund a new transistor company. You can make these transistors, and you can locate it in Culver City, which is a suburb of Los Angeles. And William Shockley says, I don't think so. And so his mother, who had graduated from Stanford and lived in Palo Alto, kind of influenced him to move back up, and he started his company then in Mountain View, Shockley Transistor in Mountain View in 1955. Again, another plug for putting things in the Silicon Valley near Stanford and near the existing companies and the existing production technology. So at the end, the situation had changed considerably. The peninsula, the San Francisco Peninsula and the Santa Clara Valley were now major electronic centers, and about half the microwave tubes were built here. Every advanced weapons system or space system had these devices in them. The industrial goods being made for radio broadcast, for television, the microwave ovens, that technology came out of this area. Now, why did that happen? Well, probably part of it was the business climate. In the East, you had large vertically integrated companies, Raytheon, IBM, AT&T. They had a big focus on protecting their current products and also protecting their markets. And they were slow to adjust to technology. They didn't have to adjust rapidly because they controlled their markets. So they didn't adapt quickly to market changes. But in Silicon Valley, it was different. They were highly fragmented companies with very decentralized. There were lots of specialized firms, engineering driven, pretty fast at developing things and very flexible at jumping from one thing to another or finding some new application. There was also this dense regional network locally of all these small and medium-sized firms that could support each other, and they could draw on this common workforce. One of the key points was that California had a law that didn't allow you to enforce non-compete clauses in employment contracts, and therefore it was easy to go from one company to another, and that was not true in most other states of the United States. So we adapted more rapidly to change, and the people who did well they thrived in this new competitive environment. So some of the practices and skills that we developed here and the competencies were developed in those early parts of the 20th century. A lot of it was just practical hobbyists collaborating and sharing together. And I've described the analog developments, but then it developed in the 60s and 70s into digital and then into software. Biotech started here with Genentech. We went into mobile. Big data has been hot the last 20 years. Deep learning, virtual reality, and now autonomous vehicles. It's all happening here to a large extent. There are a large number of cutting-edge entrepreneurs supported by engineers and venture capitalists that can help them find their dreams and develop their technology. Good local universities doing research and development work, and a lot of supporting industries. And so there are also good role models. So in our neighborhoods, we expect kids to learn how to program and work with their friends on starting up new companies while they're in high school or in college. And so it's this special culture of innovation that started way back with the ham radio operators, a lot of other or hobby groups, and including the homebrew computer club and meetups and things like that. And for example, a lot of companies have been moving here over the last 20 years. We had Ford wants to hire another 100 people in Palo Alto. General Motors wants to hire 1,000 in San Francisco. Toyota is investing $1 billion over the next 10 years. Most of it around the Bay Area, some of it around Boston. Mercedes has been here for many years. The upper right, you see the U.S. Patent Office has opened an office here. Down at the bottom, Samsung, big Korean company. They keep buying small companies, but they can't convince the engineers to move to South Korea. So they've built a huge 10-story building, and they simply buy local companies to get the employees and say, okay, you're on the third floor in the south wing, and let's see, you're on the second floor in the north wing. And so they're building this group that will be their innovation center for their operating system, for robotics, for production capability. Lower right, Walmart, an Arkansas grocery store and marketing company, has had their development labs here in the Bay Area for the last 20 years. This is where the technology for their distribution system and control system developed. So when you talk about Silicon Valley, where is it? Well, if you look at a map, this is one from 2013. I've circled Silicon Valley there, and it kind of goes from Gilroy to Palo Alto, but really, Silicon Valley now is more of a metaphysical space. It goes from Santa Cruz and San Jose up to San Francisco and Berkeley. So when something happens in San Francisco, they say it happened in Silicon Valley because it's kind of this whole Bay Area ecosystem now. Well, how different are we? I like Thomas Friedman. He's an editorial writer for the New York Times. He said, in Silicon Valley, great collaborators are prized. In Washington, D.C., they are hanged. When they say collaborator, they mean traitor. Here in Silicon Valley, we mean colleague. So in Washington, D.C., you wouldn't want Democrats working with Republicans, for example. That's not allowed. But out in Silicon Valley, collaboration, competition and collaboration, as I said earlier, that's our theme. And it's really our attitude. We think of failure as a feature, not a bug. And so instead of having a failure in a small company, we just say we rotate and try something new. And one of the themes of one of our local companies is move fast, break things. So we're not sitting around on 5-year development schedules. 90 days, 120 days, that's kind of what we're after. And you may remember from Star Wars, Yoda says, do or do not, there is no try. So very often we see very high levels of commitment out here. They're gonna do it. If it's 18-hour days for 4 months, it's gonna happen. So it's kind of the attitude. Talking now about the Electronics Packaging Society and our Santa Clara Valley chapter. Well, in 1949, Charles Eldon, we know him as Bud Eldon, he had a fratmate, Fred Terman Jr., who was the son of Fred Terman, grandson of Louis Terman. Fred Terman's brother is Lou Terman, who was the president of IEEE a few years ago. Anyway, Bud Eldon wanted a reference. He wanted to find out about who he could talk about writing articles with. And so Fred Terman advised him to talk to Don Fink in San Francisco, who was the editor of Electronics Magazine and became the IRE president, a predecessor of the IEEE. And he was the first general manager of the IEEE. So Don Fink suggested articles he might write and got him published in Electronics Magazine. Well, he went on to work at HP for Barney Oliver, who had come from Bell Labs. He was the head of research at Hewlett-Packard. And in 1955, Barney came down and sat on Bud's desk and says, Bud, Bill wants you to start an IRE group on product engineering. When somebody said Bill wants, that meant Bill Hewlett, and you obviously wanted to comply because you were in Hewlett-Packard. Bud Eldon set out to start this new product engineering group. He gathered, as we probably would do today, another bunch of volunteers from the local companies, from Varian, from Stanford Research Institute, Lytton, and other local companies, and formed an IRE, that's the Institute of Radio Engineers, product engineering group. And it merged with the Component Parts Group and PMP and others, and in 1962 formed the IEEE. They joined the Manufacturing Technology Group, which became Components, Hybrids, and Manufacturing Technology, and then CPMT, and now the Electronics Packaging Society. And so here's an example of using networking and volunteers, kind of a Silicon Valley trademark, to start a new part of IEEE. Well, here's a diagram of the journals over those years. There were many mergers. There was a big expansion. I show when I was VP of Publications, we started with about 800 pages, and by the time I finished, there were 1,800, so we more than doubled the journal. And by doing some interesting things, we generated about 4 million more than they thought we would and created quite a surplus. Well, if I look at the lower right of that diagram, at the bottom I see the formation of this predecessor group, which became product engineering. In the middle, I see when Bud Eldon became the PHP president. He was president of our society back when it was called Parts, Hybrids, and Packaging. And then in 1986, I think he became IEEE president of the IEEE. He was, I think, the only electronics packaging member who became president of the IEEE. He was also a Region 6 director. Region 6 is the western states of the IEEE. He did quite a few interesting things, but being a practical engineer, he was most proud of his contribution of changing the IEEE policies to open the fellow grade to practicing engineers. Before then, it was primarily academics because you wanted a long list of published papers and so on. But he opened it up by saying that you could have practical developments, and furthermore, they could be secret. If you were working in, say, IBM, you could have other IBM known engineers certify that you develop these things, even though you can't talk about them because they're still trade secrets or parts of products that haven't yet shipped. And so this opened it up for people like myself and others in electronics packaging to become fellows of the IEEE. So I'm glad you had this opportunity to review with me those good old days and how the technology developed, the device technology, the manufacturing technology that happened here on the San Francisco Peninsula, and a little bit about the Electronic Packaging Society's history. And so I'd like to let you know, first of all, there's a fuller version of this mounted on Stanford University's YouTube channel. So on YouTube, you can search for Stanford Silicon Valley, and you can call up the full 1-hour talk. You can also download the slide set. I've expanded it with some additional slides and a reading list. at this location. I'll keep this on the screen for a while. But that kind of wraps it up. Ken?
Yeah, well, one of the things that comes out of that, one of the first comments, you mentioned early on the difference in culture kind of between the East Coast and the West Coast back in the early days, the 1910s, the 20s, and it being much more egalitarian and democratic in Silicon Valley.
Yes.
How did that play into kind of the way things operated in the companies as far as union versus non-union and what engineers could do versus what they couldn't do?
The atmosphere in the companies was a significant part of that because there was a pretty free flow of information and activity among the various employees of the company, and they were paid pretty well. You didn't see unionization out here except in very few instances. And so rather than having unions that might slow things down and cause maybe difficulties for product development or production, you found people working together, as we often see today in Silicon Valley companies, developing things. So I think that the practices, the progressive practices they adopted, kind of thwarted the development of unions. I don't know that they actively fought against unionization, but it didn't seem to take hold here.
Well, and it seemed like another common theme was, and I've seen this with really good engineers, it doesn't really matter the education they have, the formal education, but it's that passion. It seems to be the common element there among these pioneers.
Generally, when you go into a meeting with people, you're not looking at their credentials, you're looking at what they can contribute. And since you've got a project, you don't spend a lot of time on, well, where did you get your PhD or what did you do before? Show me what you know now. Tell me how to solve this problem. And so it's a very practical, hands-on, what I think of as a rational approach to developing your team. And so you're very quick to integrate somebody into your team who can make a contribution. Diversity plays a big part because you want a lot of ideas. You don't want places where they shut you down. As I mentioned at Tandem, we encouraged new ideas, even if they were dumb. It didn't matter. The idea was you wanted people to contribute things because some of those were going to be key nuggets that you could use in solving the problems and getting that product out earlier or with better features or something like that.
So post-World War II, you've kind of got this foundation laid of a kind of a different kind of environment. So how did this translate into kind of some of the things we see now? I mean, you started, I guess, the classic example with Apple, but, we've seen more of those. Why don't you comment on that, if you could?
Sure. So we had a number of companies that I talked about in the earlier days. The California, let's just take a quick look here. In the lower left, you see a red dot, and that's the population of California. And the gold line up above is New York's population, which was twice California's. But if you follow that blue line up and across, it's got hockey stick look. That's California's population. And by the time you get to these days, the 2010, you see the California population is twice that of New York and twice that of Florida. So there was huge growth out here. A lot of it stimulated by aerospace and airframe development in Southern California, electronics in Northern California, and just the movement of people to Los Angeles and the San Francisco Bay Area. So upper left, you see Shockley Semiconductor. That was the company that I mentioned. Fairchild sprung off from them. The traitorous eight left and formed Fairchild, which formed all the Fairchildren, a lot of electronics companies. In the upper middle, you see the Stanford Research Institute. I like to ask people, if you've got an iPhone, why did they call that intelligent agent Siri?
And why did they?
Well, because SRI is too hard to pronounce. So if you put an I in there, it's Siri, and the technology for Siri was developed at SRI. A couple of guys went off and started their own little company, which Apple bought, and so they just kept it named Siri. In the lower left, Stanford and UC Berkeley. We also have San Jose State and Santa Clara University. In the right-hand side, you see Hewlett-Packard, and then underneath, Varian Associates, the very first company to move into Stanford Industrial Park, and General Electric, which was the third company with their microwave tube division. Then in the 60s, we had the semiconductor companies, AMD and National and Intel and Intersil. We had Memorex developing disk drives. Applied Materials, here we have a company making equipment to make semiconductors. That became a whole new industry with Lam and all kinds of other companies. In the 70s, we get computers. There's Tandem Computers and Apple and Amdahl. Lower left, Atari is now making video games. This is amazing. And on the right-hand side, on the upper right-hand side, you see KPCB. That's Kleiner Perkins. That's our big venture capital company, Genentech. In the 80s, we get into software. Now we've got Adobe making this wonderful graphics editing software for the Macintosh and for the PC. We have Cisco developing routers for what became the Internet. In the lower left, Silicon Graphics, MIPS and Sun with workstations, very high processor power workstations. The lower right, Fry's Electronics, one of my favorite stores. In the 90s and beyond, we get Tesla in the upper left, starting to make electric cars. We've got Google and Facebook developing search engines and social media. Lower right, you have Salesforce developing cloud-based systems, Netflix and Pandora, and lots of other companies all developing out of earlier ideas and developments. So those are some of the things that happened since then in the Valley. And I think that the fact that the cultural climate encourages that sort of thing, the venture capital has come here. It's quite amazing, but we keep seeing this happening, and I think it'll continue for quite a few years.
One of the interesting things is it seems like this technology, a lot of what's new really isn't new. It's just that the pace of the stuff needed around it has caught up to it finally. It takes a while, it seems. And
the infrastructure, too, because artificial intelligence, a lot of that theory was from the 60s and 70s, but we didn't have the processing power. And now NVIDIA makes neural network type, deep neural network computing devices out of their graphics processors that allow us to have intelligent cars, autonomous vehicles, things like this, because it's something we couldn't do before. But now the technology is caught up. Electronics packaging, device technology, computer architectures have caught up to the point where we can implement things that we dreamed about back when we were in college or were young engineers.
Well, it's very exciting, and it continues to be exciting. And what sort of technologies kind of excite you for the future?
Well, so what are the possibilities? Just here's a quick slide on where I see innovation today. We see the old homebrew computer club kind of stuff happening in meetups. Meetups tend to be supplanting IEEE's chapters these days. Maker Faire, Tech Disrupt. On the right, you see incubators. So we've got our 500 startups. That's a company locally that helps startups. And Y Combinator, very famous as a startup incubator. There's one called Indie Bio for startups that are involved in biotechnology. And we have shared office spaces or development spaces like Rocket Space and AngelPad. There's a lot going on in open source. For example, the Open Compute Project with Facebook and Intel and Google and many other companies developing inexpensive, high-speed, focused processors for work in mainly on internet applications or mining bitcoins or things like that. And a very egalitarian software development, the open source software space, kind of like the old ham radio, people getting together. It's a bunch of hobbyists get together. I belong to about 4 different meetup groups, and so I'm going to sometimes 1 or 2 meetings a month of like-minded people trying to develop and help each other. But as for where we've been, I think currently a lot is going on in the cloud space with Azure and the Amazon Web Services and Google and Microsoft and HP and IBM. Blockchain, I think that will extend to contracts and into real estate, documentation of real estate deeds and so on, in banking, in energy development and use. Smart agents, I mentioned Siri. We've got others that I think will help us as deep learning helps us tap other information or do things with our intelligent agents. Home networks are part of that also. And the new U.S. Supreme Court ruling on design patents, I think, makes a major change. Utility patents, you've always had to look at what your patent infringement might have cost the other company, and the payouts or the penalty was based on that. Design patents, if you have a rounded corner on your iPhone and Samsung comes out with a rounded corner, then everything Samsung makes on all the profit has to go to Apple. Well, the U.S. Supreme Court said, no, that's not true. You've got to base it upon the individual part. This is a major change, and I think it'll focus well on developments in technology. But what's coming? So platforms, I think the cellular platform, we're very familiar with that. It'll continue to develop in smartphones and mobile and wearables, smart watches, things like that. But a new area is vehicular technology. After all, we think of cars as an engine and a bunch of wheels. Really, it's a bunch of computers that just happen to have wheels attached. And that's a platform that's ripe for lots of development, and we're seeing lots happening there. In the area of virtual and augmented reality, I think mainly augmented reality is going to be a big area, and companies are focusing on that for training, for supplementing what you can find out about things. Walking down the street, you can see a building, and you can now see what's inside, what kind of services you might find there using your augmented reality glasses. Deep learning undergirds all of this. The sharing economy, I think this is going to make a big difference. Perhaps get a lot of cars off the road. Mm-hmm. You won't need as many parking lots anymore. So I think that there's going to be a lot of changes over the next 20 years through the sharing economy. Artificial and machine intelligence. Industrial analytics. I think especially in electronics packaging, the industrial Internet of Things is going to be big. Being able to put sensors and controls and things like that into the factory and into the production environment and into the use environment, as General Electric does on their steam engines and on their airplane jet engines. They're instrumented. So they tell you, gee, I'm feeling a vibration here. I think in 500 hours you ought to pull this engine and rebuild it. And that information goes back to General Electric so they can monitor their products in the field. This industrial analytics is a big area. And drones and autonomous vehicles. I think those are all kind of things we're going to be seeing affecting our developments here and around the world.
Well, that makes sense. And one of the things that you touched upon is just still the importance of face-to-face with the meetups that you go to. And I think that is one of the things that still makes this area special, is that serendipitous thing of being able to run into people at church or wherever it is, the grocery store, right?
It's neat to have this critical mass of nerds so that you can find people locally within probably 30 miles. You can probably find a lot of people. One story I tell is about Steve Jobs and Steve Wozniak. They lived a few blocks apart, but Steve Jobs knew Bill Fernandez, and Bill Fernandez knew what Steve Jobs was interested in. He says, you ought to meet this Steve Wozniak guy. So he introduced the two of them out in front of Steve Jobs' house, and that's how it started. It was just that critical mass of nerds is pretty high here, so that chances are you can find somebody else at your high school or at the local bar or whatever, and or just through social media now, because we have meetups, so that you can search for a technology and find there's a local meetup, one in Cupertino, there's another one in Saratoga, and one in Oakland, and you can join all of them or several and work with similar like-minded people.
Well, Paul, I really appreciate your knowledge and your time today, and thank you everyone out in the internet for attending, and thank you again, Paul.
Thanks, Ken.
Thank you. I want to thank Paul, Ken, and all of you for attending the webinar. A copy of the presentation will be posted shortly on the website and sent out to the registrants. So thank you, everyone, and please take notice of Paul's contact information if you have any follow-up questions.